Hey you. Yeah, you. I bet you know all about linked lists, don't you? You've been programming for years now, and if you got pinned in an interview and asked to do some silly linked listy things, no problem, am I right? In the early 2010s, I interviewed at Google, and I figured that I had over 15 years of experience. I'd been studying for months. I should do okay, shouldn't I? The interviewer hit me with a curveball. Write me a linked list from scratch. Let's see what happens. And that wasn't something that I studied, but I was game. Let's just say it didn't go very well. I failed the interview. Question does seem easy, but some of the logic can be tricky. At least it was for me. I don't want this to happen to you, so let's dig into the linked list. In today's video, we're going to discuss the mighty linked list, one of the core data structures in computer science, and annoying interview questions, and something you really should understand as a programmer. Most experienced programmers think things like this are lame. Who has to write linked lists from scratch? The answer, no one, which is exactly why this is a great interview question. As you may or may not know, a linked list is simply a node pointing to another node in a chain, each node containing some kind of value. A linked list is null terminated, meaning that there is no next node for the tail. That's how you know you're at the end. Finding a node in a linked list is order n, meaning there is no index or key lookup. You have to traverse the whole thing to find the node that you're looking for. Those are the rules. Can you code this up for me? And if you're new here, I write books and make videos over bigmachine.io specializing in the basics, as well as handling tough interview questions like this one. If you'd like to support my efforts, drop by and say hi. Also, if you subscribe to my YouTube channel here, you'll receive a free copy of JavaScript in the mail. Now, in the computer science sense, a linked list differs from an array in some important ways. Arrays are constructed in contiguous memory and cannot be resized. A linked list, on the other hand, is just one value pointing to another. Linked lists are slower because you need to traverse them for everything. No index or key-based direct access. You have to think about memory and deallocation if you're using an older language like C. Finally, linked lists can change size as needed. Arrays can't. Again, this isn't computer science. Now, you might be thinking, Rob, I use arrays every day in my favorite language, and I can resize however I need to. Duh. And I would say, sure, friendo, but we're talking computer science here, specifically data structures, and this stuff is important when asking really lame interview questions. So let's move on. Let's talk about the methods of a linked list. The method most associated with a linked list is, of course, append, which appends a node to the end of the list, also known as the tail. There are also methods or properties that tell which node is at the head and optionally the tail. You need a way to traverse the list, so a traverse function is also useful. There's also the remove method, which will remove a node at the tail of your list, if there is one. Now, if you're in an interview setting, hopefully not grumpy, and your interviewer asks about removing a node, make sure that you include something about deallocating the value from memory as well. Remember, this is computer science, not your favorite language. You might not always have a garbage collector. Remove should also be able to work in the middle of the list and should knit the adjacent nodes together. Same with insert. You should be able to drop a value in the middle of the list, pushing things right and making sure the associations are kept. All right, you got all that? Would you be grumpy with me if I asked you to create a linked list from scratch in an interview? Of course not. This stuff is fun. No, seriously, can you create one for me? Pause the video. Seriously, give it a whirl. Let's step through this process. I think it's a good time. It's a bit of a puzzler, and I like code puzzles. A linked list in the purest sense is a bunch of items or nodes linked together. We can formalize this with a class with two properties, value and next, and a single method, append. This is all you need to create a linked list. If you're asked to create one from scratch, well, this here is a fine answer. We can create a linked list by creating a head and then appending nodes to it. The last one, of course, being the tail. I'll add some code here to loop over our list and then print things out so we can see if it works. Running this, and hurrah, we have a linked list. If you're in an interview setting and you're asked to create a linked list from scratch, well, this is all you need to create. But be careful. If you head to a site like LeetCode and you look up design a linked list from scratch, you're going to see a whole lot more than what I just wrote. You'll see prompts like this one in JavaScript. Solutions to these questions up at LeetCode can be complex. It's super tempting to put everything in a linked list class. In fact, that might be the solution your interviewer wants to see. But in the purest sense, a linked list doesn't have any behaviors. It has a value and a pointer to the next value, and that's it. You can do a lot with a linked list, sure, but those are list operations. Let's take a look at those. Let's traverse the list that we just created. This is a straightforward algorithm and one that will be used by every other function we'll create, almost. including insert and remove. Here I take in the node to start from, and also a callback. I then loop over the current node, which I'll default to the start when it comes in. I'll fire my callback with a current node, and if there's a result, I'll return it. I'll up my counter and repoint the current to the next node, and that is that. Because linked lists are null terminated if next is null, we're done. We'll need to find things in our list, and we now have two ways to do it, by value and by position. I'll call the function that finds by value find and by position get. Both will use traverse to loop over the list. Finding things in a linked list is always order n. There is no key lookup like you might find in a hash table or a dictionary. Let's try it out and make sure everything works. I'll find the node in my list with a value of 2, and I'll get the value in my list at position 3. Note that I'm using a zero-based position as well. Running this, and groovy, we found a node with a value of 2. We also found the last node with a value of 4 with no successor. It works. Inserting is the next thing we'll need to do. Here I'm inserting a value after a given position, but you can also insert after a value if you want using find. The trick to this is how to actually perform the insert. In an interview setting, the logic behind this can be unnerving. Imagine you're having to write this on a whiteboard. You have to make sure you're setting the next property for both your new node and the node behind it. If this doesn't make sense, stare at it a bit, maybe draw it out. Notice also that I'm returning the starting value back. This is good form because the list is now altered. So let's be sure that our calling code can loop over the changed bits. This is another thing your interviewer is going to want to see you do. Let's test it out and be sure that we know what we're doing. I'll create a print function that loads an array in JavaScript and prints it out using join. I'll insert 99 right after the second value in our list, so it should appear right after the 2. And running this, look at that. It's almost like I practiced this for over an hour. Hopefully you're starting to see that this is a fun interview question. The logic is not that straightforward and makes a fun puzzle, I think. Removing something is a little bit trickier though. Once again, we're going to remove by index, but we could also do this using find. The trick to removing something is to make sure that you avoid errors. One place people screw up a lot is how to handle a case when you remove the head. Another is to be sure there's something to actually remove. Finally, we are once again making sure that we return the starting node, which is usually the head. That ensures that the calling code can loop over the changes made. Once again, we will make sure it's all working by removing the value that we just added. I'll insert 99 at the second position and then remove it and then print everything out to the screen. And running this, how lovely is that? Now for one of the most hated interview questions ever. Reverse a linked list. I've done this exercise so many times, and every time I try to do it from memory, I end up banging my head against the desk because I just can't remember it. The trick here is that we can't use our traverse function. At least I couldn't figure out how to do everything with deadlock. We need a specialized loop for this. That special loop needs 3 variables, previous, next, and current. So how would you implement this logic? It's a bit of a brain bender. Test yourself by pausing this video. Give it a whirl. No, really, I'm actually not kidding. Try it. You'll want to kick yourself. Well, I want to anyway. Kick myself, not you. The trick here is to use a while loop, ensuring that we have a current node. We then assign in order next, setting it to the current next value. We then reset the current next value to the previous node, which reverses things. Previous is then reset to current. Current is reset to next, moving the loop forward. When current's null, we make sure we pass back the previous node. I was going to work up a fancy graphic for this, but I'm guessing you can visualize the concept of reversing a linked list in your mind. Translating the concept into code, however, well, that is the tricky part. If this looks confusing, pause the video, step through the process. You'll get it, I promise. Why is any of this important? Does anyone really care? Why, yes, friendo, I have a habit of asking the most basic, ridiculous questions in interviews because those are the most entertaining.
Is this really happening? He can't even boil a f***ing egg. F***ing thing's still got feathers on it.
But on the positive end, coding puzzles can be fun. If you got grumpy with me in an interview because I asked you to make me a linked list, would I really want to work with you? Probably not. And you probably wouldn't want to work with me either. That is why I like to ask these questions. All right then, well that's it for me. Hope you enjoyed this video. There's a lot more where that came from up at bigmachine.io. I hope to see you there. Thanks for watching. I'll see you again soon.